All right. Let's have a little review problem that is combining something, what we've talked about, cardinality from the first half, and what we talked about with relations from the second half. So here is maybe a true or false question. The set of relations on the integers is countable. So how would we approach a question like this? It's a cardinality question because we're asking if this set is countable, or what is the alternative, or if it's uncountable. And remember that with cardinality arguments, the general way that we do this is by breaking it down or relating it to things that we already know about. So let's try to do that. But where do we start? We're working with the set of relations, so we need to start with what is the definition of a relation. So let's start with that. Recall a relation on the integers is simply a subset of integers cross integers. Remember, we think of it as the subset of pairs A, B, where A is related to B. But it can be any subset. They don't have to be related in a way that you can say in words. Writing down the subset is essentially declaring which elements are related. So, updated question. What is the cardinality of the set of subsets of Z cross Z? So this is still not something that's completely obvious, that we've seen very concretely before. But at least the set of subsets should be an operation that we recognize. In fact, let me erase that and replace it with the name that we know it by, which is the power set. So what is the cardinality of the power set of Z cross Z? So now that we've written it like this, maybe we remember some facts that we have proved about the power set. Maybe we didn't prove them, I'm not sure, but we know them to be true. Here is a fact that we know to be true. For any set A, the cardinality of the power set of A is strictly larger than the cardinality of A. So applying that to our situation here, the cardinality of the power set of Z cross Z is strictly larger than the cardinality of Z cross Z. So that will tell us something if we know what the cardinality of this side is. And I believe we do. This is just the same as the cardinality of Z. It is countably infinite. And that implies, since this thing is strictly larger, it must be uncountable. So here, we find that this set is uncountable, and that's exactly the set of relations on Z, because the relation on Z is a subset of Z cross Z. So what's true is that the set of relations is uncountable, and this is false.